Welcome, Math 13 students. Today I have a PowerPoint lecture for section 3.1. We're going to look at basic definitions. So let's go ahead and get started. All right, so section 3.1, measures of center. So this is the first section in chapter 3. We really start to use our calculator here in chapter 3. You'll see that on some other videos. I'm going to focus here on definitions. So, bit of an outline first. In this presentation, we will do the following. We will define various measures of center. We will determine rounding rules, and we will include appropriate examples. Definitions. A measure of center is a value at the center or middle of a data set. A measure of center is a representative value for the entire population for sample. It has clear notation, correct rounding, and correct units. There are several measures of center, but before I get to the basics, let's take a look at some detail. First, an outlier. An outlier is a data point far from other data points in a sample or population. A statistic is resistant if the presence of an outlier does not cause it to change by very much. Now recall that a statistic is a value describing some aspect of a sample. Notation. We use X for individual data values. We use little or lowercase n for sample size. We use big or uppercase N for population size. We use the summation symbol with X as a way to conveniently notate repeated additions. That funky thing on the right is the Greek letter sigma, capital sigma at that. More definitions. So the mean of a set of data, we sum the values and we divide by the number of numbers. It goes by a couple of different names, the mean, the arithmetic mean. Most students know this as the average, although we usually don't use that phrase in statistics. So X bar is equal to the summation of all the X's divided by the number of numbers, or the sample size. So X bar is the name for a sample mean. We call a population mean by the Greek letter mu. Sum up all the values in the population and divide by the population size. So you can see both those formulas are some form of add up the numbers and divide by the number of numbers. It's your basic average formula. Here's a very quick and simple example. We have a sample of Verizon data transfer rates in megabits per second. There's 4 of them there. If I wish to find the mean, I'll do the following. X bar equals, and I'll sum them all up and I'll divide by the number of numbers, 4 in this case. When I take that into account, I get 32.7 megabits per second. So you'll note that I've got the X bar notation. I got 32.7, which is the correct rounding here, and I have the units involved, megabits per second. Properties of the mean. There are advantages. Sample means vary less than other measures of center. And the mean of a data set uses every value in the process of the calculation. There are disadvantages. Just one outlier can change the value a lot. Therefore, we say the mean is not resistant. More definitions. The median. The median is the middle value when data values are arranged in order. To find the median, we place the data values in order and we find the middle number. There's no real formula and no real hard and fast notation. I usually just write the median, the word median to mean median. Sometimes you run across X, I guess that's tittle, but I just write median. Here's my example. Vehicle speeds in miles per hour. Excuse me. Find the median vehicle speed. I arrange the numbers in order. The middle number is 54. So we have a median of 54.0 miles per hour. And I'll talk about why we use that zero in a bit. You'll also note that the number of data values is 5. That's an odd number. What if the number had been an even number? You can take a look at my office hour lectures to see an example of one of those. Properties of the median. The advantages. Outliers do not change the median by large amounts. Therefore, the median is resistant. There are disadvantages. The median does not directly use every data value. We really only use the middle number after we've arranged them in order. More definitions. The mode. The mode is the data value that occurs most often. A data set may have one mode, two modes, or more. Might be quote unquote either bimodal or multimodal. Or there may be no mode at all. There's no real formula here either, but we count and we see which value appears the most often. It's like a vote in an election. Here's an example. We have the number of computers in a household. We have a fairly large sample there. We want to find the mode. I note that the number 3 appears more often than any of the other numbers. Therefore, the mode of this sample is equal to 3. We have properties of the mode. There are advantages. Well, one of the biggest advantages is that we can use it with qualitative or categorical data, like eye color, favorite ice cream flavor, things like that. There are disadvantages. Well, a data set can have one, none, or several modes. More definitions. The mid-range of a data set is the value halfway numerically between the maximum and minimum values in the data set. It's rarely used, and I really kind of cover it probably because I just should. It's also one of the few in this little list that actually has a formula. You find the maximum number, you find the minimum number, you add them together and you divide by 2. Some of you may recognize that formula as essentially the same formula we use to find the point in the middle of a class of data in frequency distribution back in chapter 2. Same type of formula, does the same thing. Here's an example. Oh, let's go back to those household computers. Find the mid-range. Well, they range from a low of 0 to a high of 5. 0 plus 5, I add that together and divide by 2. So we have a mid-range of 2.5 computers per household. Properties. As I said, it was rarely used. And there are really no good hard and fast properties that we this semester are going to encounter. They do exist, but they're at more advanced levels. Disadvantages. Most of the data values are not used, only 2 of them. The little one and the big one. And that's about it. Now, let's talk a little bit about rounding these types of values. We have we have a number of rounding rules this semester. A lot of them are really based on this particular rule we're about to use. Some of them are a little odd, but really not. So for the mean, the median, and the mid-range, we want to round our data, our summary data, the statistics, to one more decimal place than in the original data set. For the mode, we leave the data value as is without rounding. We really just report the mode. So the mean, the median, and the mid-range, one more decimal place than the data values. The mode, there's no real calculation, so there's no real rounding. You just tell us all what you found. And we also need to apply some critical thinking to this type of process. We can always calculate measures of center from a sample of numbers. Sometimes the question really is, does it make any sense at all? So, a final example. Here are some zip codes. I chose them at random. And I can find the mean of those four numbers. The mean is 94466. That's also a zip code, I suppose, somewhere. But I got to note that zip codes they define geographical regions. So things like the mean, the median, and the mid-range really make no sense for that type of set of numbers. However, it is potentially important to be able to calculate the mode. You might be able to use the mode. I'll bet you anything. In places like Amazon, who ship to different zip codes, know gosh darn well which zip code is the most popular. So they have a real need for something like the mode. But the other measures of center really make little sense here. So a little bit of a summary. We have defined various measures of center: the mean, median, mode, and mid-range. We determined our rounding rules, and we've included some appropriate examples. So I've now walked you through the definitions for section 3.1, measures of center. Take a look on our Canvas course shell for detailed videos on how to use your calculator to make all of these calculations. Thank you. I'll stop sharing, and I'll say goodbye. Bye.